Hello and welcome to more of power rules. So an exponential rule. So let's take a look. We already had a review on this. We're going to do a little bit more now. So I'm going to just let you look at this and do it yourself while I wait for you just a few seconds. You've got 2 squared to the power of 4. You know what to do here. Times 2 cubed to the power of 2, you know what to do here. And then when bases are the same and you're multiplying, you know what to do to the exponents. So do it. And then the same thing here, bases are the same but you're dividing, so you know what to do with that also. Okay, so if you have not finished, it means you don't know what to do, because if you knew what to do, it's fast and it doesn't take a lot of time. So let's just have a quick review. We know that when we have a power to another exponent, we're going to multiply these. So 2 times 4 is 8 times 2 to the power of 6. And we know when we're multiplying and the bases are the same, we add the exponents, and 6 plus 8 is 14. 2 to the power of 14. So we're just going to leave this as a power. We are not going to evaluate. Here, what do we have here? Here we have 3 to the power of 8 divided by the power of 5 divided by to the power of, what's that power there? 1. If you don't see anything, it's a 1. So now this is really 3 to the power of 8 minus 5 minus 1. And 8 minus 5 is 3, and 3 minus 1 is 2. And that's it. That's all you need to do. This is showing your work. This is the answer. Okay? So when your teacher says on the test, show your work, that's what they mean. Show your work. If you just go straight to here, they don't know if you just guessed or what you did. Show your work. It's not like you had to take a week off of school to write this up. It takes 2 seconds, so just write it up. Now, let's take a look what's going on here. Now we have letters and numbers. You know these letters are called variables because they vary depending on what you plug in for and substitute in for x and y. But the rules are the same. If the bases are the same and you're multiplying, you add the exponents. If the bases are the same and you're dividing, you subtract the exponents. And then we also have this stuff. So we've got like a combo here. We have a combo of several different exponential laws. So here, this one is simpler than this. Let's do this first. So here we have 2 times 9 is 18. And then we have x to the 3 times x to the 1. So that's x to the 3 plus 1. And then we have y to the 4 plus 2. And then we just simplify. Again, 2 times 9, we already did the 18. And then this is x to the 4 and y to the 6. Okay, now let's take a look at this one here. Here we've got this divided by this. So first let's do everything in here. I'm going to actually just go over here for a second. If we have something like this, 3xy squared, what that means is we're going to square each thing in the bracket. So that means we're going to square the 3, we're going to square the x, and we're going to square the y. Okay? And then, of course, that's equal to 9x squared y squared. So now that we know that, let's take a look at this. We have this negative out front, so let's leave that there because we don't do multiplying before we do exponents in BEDMAS. And then we're going to do 2 to the power of 5, x to the power of 5, y to the power of 5, and z or z to the power of 5. Then we're going to divide by 4 to the power of 2, x to the power of 2, y to the power of 2. So let's see here what we have. This is negative 2 to the power of 5 is, do you have that memorized yet? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the power of 5 is 32. So we have negative 32, x to the 5, y to the 5, z to the 5, divided by, what's 4 squared is 16, x squared, y squared. And now we're going to do exactly what we did over here, but instead of multiplying 2 times 9, we're going to divide negative 32 by 16 because the question says to divide. So what is negative 32 over 16? Well, I'm hoping that you know that that's negative 2. And then we have x to the 5 and x to the 2. So what's 5 minus 2? So that's x to the 3. And then y to the 5 and y to the 2 is y to the 3. And then z to the 5 and no more z's leaves us just z to the 5. Okay, let's take a look at this one here. So here we have 3x squared y, there's no simplifying to do with just that, times, now you'll see how the negative is in the bracket. That's different than when it's out in front of the bracket, right? So this is negative 3 to the power of 2 as opposed to 2 to the power of 5 and then multiply it by a negative. So anyhow, here we have negative 3 squared. So what's negative 3 times negative 3? Positive 9. And then we have x squared, y squared. And this is all over 3 to the power of 4. So that's 3 times 3 times 3 times 3, or 9 times 9, which is 81. And then x to the 4, y to the 4. So let's continue simplifying. We now have a fraction. Okay? So I'm going to do some canceling. Here we have 9. We know that 9 over 81, 9 goes into both of these, so 9 goes into 9 once, and 9 goes into 89 9 times. If it's getting a bit messy, then we can do another line, but I'm going to try and see if you can follow by just doing it right here. Now we have 3 over 9. 3 over 9, well, there's a number that goes into both of those, it's 3. So here 3 goes into 3 once, and 3 goes into 9 3 times. So now it's really getting kind of messy. Let's just clean this up a bit. So now I have 1 times x squared times y times 1 times x squared times y. So 1 times 1 is 1. X squared times x squared is x to the 4. And y times y squared is y to the 3. All over, this is a 3. X to the 4. Y to the 4. Okay, so I'm going to have to go this way because I'm out of space and there's more reducing to do. So here we have a 1 because there's nothing there, so a 1 over 3. And then here we have x to the 4 over x to the 4. And we know anything over itself is always just equal to 1. And then here we have y to the 3 and y to the 4. I'm going to write this like this, y to the 3 and y to the 4. That's what we have left here. Now remember that this is dividing with bases the same, so we're going to subtract these. So there's two ways of looking at this. You can go like this or you can go like this. Let's explore both for a moment. Here we've got y to the 3 minus 4, and then this 3 is still in the denominator, so we leave it there. And that ends up equaling y to the, what's 3 minus 4? Negative 1 over 3. Here, I want you to look at this a different way. So this is y cubed, so that's y times y times y over 3 times 1, 2, 3, 4 y's. Now let's reduce. Those y's cancel, those y's cancel, and those y's cancel. So what's left up here is a 1 over 3y. Now I want you to notice something here, which I don't think you've learned yet, and I don't know that you even learn it later on in this course. Sometimes they don't teach it till grade 10, but I'm going to just go over it here briefly with you, just so you understand. One of the things that is considered proper form is to have exponents in your answer that are positive. And you see how here the y in the denominator is y to the 1, and here when the y is in the numerator it's y to the negative 1. So there's something, there's a law that tells you that when you move exponents from top to bottom, you change the sign. So I'm just going to go over here for a minute and do a quick little lesson, a quick little explanation. So this is the same as this to the positive 1. This is the same as this. When you move something from the top to the bottom or the bottom to the top, you change the sign of the exponent. Okay? And that's why here we have y to the negative 1, but when it's down here, because these are the same thing, right? You can't, it's still the same answer, so these two should be equal. Here, y to the negative 1 in the numerator is the same as y to the positive 1 in the denominator.